So in this part of our video, we're going to talk about the producer surplus, which is the last piece to the puzzle. We've talked about the consumer demand curve, the producer supply curve, the equilibrium point between them where supply meets demand. We've talked about consumer surplus, which is the amount of money that the consumer feels that they have saved in the purchase of the number of units that they've purchased. So in this part, we want to talk about the producer surplus, which is the amount of money that the producer feels they are saving or gaining from producing X number of units at a certain price. Okay, so we saw in our example with the donuts that we had a producer supply curve, and that curve was an increasing function. And here we have our graph again, where we have number of units on the x-axis and the price per unit on the y-axis. And when we had both of the pictures together, we had the demand curve that crossed the supply curve at this equilibrium point, and the equilibrium quantity, the number of donuts or number of units in general, we'll call X subscript E for equilibrium, and that corresponds to the equilibrium price. So if the price is set at the equilibrium price, then the consumer and the producer both agree that they want to consume and produce this many units. Okay, so in this case, our area under the producer supply curve represents the minimum amount of money that the producer requires in order to produce X sub E units. So the area under our producer supply curve, here's our producer supply curve, between 0 and our number of units, X subscript E, for the donuts, that was 3 donuts. This area represents the area under the producer supply curve that is the minimum amount of money that the producer requires in order to produce this many units. Sometimes this can be considered the cost of producing this many units, so that this area in here represents the cost of producing this many units. So that is how much the minimum amount that the producer is willing to accept in order to produce this many units. Now, on the other hand, the next question that we might ask is, how much will the producer receive from selling X sub E units? Well, if the producer is selling this many units at a price of this many dollars in price per unit, then the money that he or she is going to receive is going to be the price per unit times the number of units. So the price per unit is our equilibrium price, and our number of units is our equilibrium quantity. This is represented by the area of this entire purple rectangle around the outside. So the amount of money that the producer receives is represented by this purple rectangle. The amount of money that he or she is willing to accept as a minimum amount is this lower triangular area, which means that this upper triangular area, this portion right up in here, this portion is kind of like icing on the cake. It's money received that is above the minimum amount that he or she is willing to accept. This shaded region right here represents the producer surplus. Okay, so now that we have our picture, let's write down a formula for producer surplus. So our big rectangle along the outside is the amount that the producer will receive. And we are going to subtract off from that the minimal amount that he or she will accept. In other words, the amount that goes toward costs or things like that. And that is the area under our producer supply curve. And so this area under that curve, that's our integral, and that is the minimum amount that the producer is willing to receive. All right, so we're going to subtract those two pieces. The minimum amount the producer is willing to receive, that's our area under the curve, so that is an integral of our supply function, or our supply curve. That area starts at a value of x equals 0. No matter which problem you're talking about, we always start at an x value of 0. And then we end at whatever x value we're talking about. In all of the problems that we'll talk about in this class, that final x value will be the equilibrium quantity. And so we have the integral from 0 up to x subscript e. And we're going to subtract that from the amount the producer receives, which is the area of this large rectangle, which is our price per unit, times our number of units. Okay? And so if we take our price per unit times our number of units minus our integral, this will give us our producer surplus. And that value should be in dollars. Okay, so this is the idea. This is the formula that you can use for producer surplus. And you might compare that to consumer surplus that we saw in the last section, or in the last part of the video. The consumer surplus, that one started out with the integral from 0 up to our quantity of our demand curve. And then we subtracted off from that area, we subtracted off the rectangle. And so these two formulas are almost exactly the same, except for the order in which you subtract things is opposite. So if you're ever working on one of these problems and you come up with a negative answer, either it means that you have a bad economy and things aren't working the way that they should, not likely in our scenarios. More likely is that you have subtracted things in the wrong order. Okay, so let's go back to our example of our donut shop and calculate the producer surplus for the equilibrium point in our donut shop. So our producer surplus at the equilibrium point in our donut shop example well, we had our price per unit was 0.07 x squared plus 0.17, and what we saw was that our producer supply curve, which is this function right up here, looked something like this. And we calculated, along with the demand curve, where our equilibrium point was, and that equilibrium point occurred at a value of 3 donuts. And so 3 is our equilibrium quantity, and that corresponded to an equilibrium price of 80 cents. Okay, so the region that we are calculating here is we are trying to find a value for this upper triangular region, and that value of that area right there tells us our producer surplus. So the two pieces of information we need are, we need the amount the producer receives, which is our rectangle, and we need the area under our producer supply curve. Okay, so let's do some calculations. So the amount that the producer receives is our price per unit times our quantity, which for us is 80 cents times 3 donuts So our producer is going to receive $2.40 for producing and selling 3 donuts. Okay. That's one piece of information we need. The second piece of information we need is the minimum amount that the producer is willing to accept. And this amount is our integral from 0 over to our x value of 3 under our function, which is our producer supply curve, and that function is 0.07 x squared plus 0.17 dx. So now I've got some calculus to do. I want to evaluate this integral. So to evaluate the integral, I'm going to ignore the bounds, and I'll start by looking at the indefinite integral. The integral of 0.07 x squared plus 0.17 dx. And I want to find an antiderivative. So luckily I don't have any fancy things being hugged by parentheses. The parentheses that are here don't have any power on the outside, so I can ignore them. And so I can find the antiderivative of each part separately. So I'll start with the beginning. I'm going to add 1 to the power, so I have x to the third. And then I'm going to divide by the new power, so I have 0.07 over 3, x to the third. The antiderivative of a number is that number with an x tacked on, and then I have a plus c. Okay, so this first part is my antiderivative, my capital F. And so I want to evaluate capital F at the top bound, which is x equals 3. So we have 0.07 over 3 times 3 to the third plus 0.17 times 3. And I crunched this ahead of time, and what I came up with is a 1.14. Okay, and then I plug in the bottom number. Capital F of 0 will be 0.07 over 3 times 0 cubed plus 0.17 times 0. That gives me 0. So now I subtract capital F of 3 minus capital F of 0, and I have 1.14 minus 0, which is 1.14. Okay, so the minimum amount the producer is willing to accept for those 3 donuts is $1.14. So that is this lower triangular area. Okay, so we've got our rectangle area, we have our integral area, and now to calculate our producer surplus, our producer surplus is going to be $2.40 minus $1.14, and what I get for that is $1.26. So the producer feels happy that they have made $1.26 above what they minimally expected to make on 3 donuts. Okay, so both the consumer is happy. The consumer surplus was 90 cents. The producer surplus is $1.26. Both are positive surpluses. We like that. And it all comes down to areas under a function. Okay, thanks for listening.